MobileNet model. There are UNet. This is MobileNet. That means they are different team when they just use create those model into some challenges or some hackathon or some in the competition. Okay. Now those model are going to be used by other developers or the users because those model are pre-trained. Okay. So it has some 97% of accuracy. Now you want to increase those accuracy of the model. So you have to apply some different data to the model. Okay. Now if the model has already trained to getting the result of 97%, so you don't have to put the similar type of data because it will not increase the accuracy of the model. If you want to increase, you have to apply some different logic. Either you have to use different functions, coding, processing of the data, or even the different type of data. Okay, so these are the logic to develop a pre-trained model. MobileNet model, Inception network. Inception network are deep neural network with some great architecture for preparing for inception model. Okay. What is inception? Is a technique that first get employed in alienate. Okay, alienate T. NET is used for network. Okay. Ali some the developer's name, first name or last name. So a successful CNN for identifying patterns in image. Okay. So this inception network is using is developed by using alienate. Okay. Even this network is used the pre-trained model, which is alienate. Now it has more accurate than alienate. Now even you can use this inception network and develop some more logic and you can create your own network. Okay. So an inception model is used when a CNN uses convolution kernels. Okay, for varying sizes as well as pooling within a single layer. These are the details of the inception module. You can see here. Microarchitecture was first introduced by ZD et al. These are the conference of the research the team. So you can see here ImageNet large scale visual recognition challenge 2004. So these model which we are using right now to develop new model, which is already pre-trained or developed in some challenges in the competition. Okay, because they are highly high level of developers, they have the team of the high level of means 10 years, 15 years, and 20 years of experience developing some different softwares, different model. Okay, so they are just making some team and just hacking those competitions. So these are the main hallmark of the architectures include utilization of different things. So these are the basic theory about the sensor model. You can read. Okay. Optimize quality, architecture design, Hebbian principle, and what they have. There are popular version of how they are just improving version 3 business. Uh, these are the details of the inception, how they are just what kind of architecture they use. 5 into 5 conveys. That means 5 into 5, 25 pixels of the data is processing at a one time. Okay. So these are the different architectures you have to understand. Okay. So it's the filter concurrence. Here we are processing one by one convolution. That means one into one matrix of the images. and 3 by 3 convolution, 5 by 5, and 3 by 3 max pooling. That means which has the max value. And now we already discussed it. Now we are just combining into the filter confidence. In the previous layer, they will just divide those images into different kernels. Kernel means convolution. That means how many pixels we are using and how the pixels are identified by some different ways. Okay, so these are the architecture of the different. Here you can understand the inception model neighbors, what how they are processing, how many data are processing at a one time. Okay, 28 by 28 into 192. This is the multi-dimensional data. Okay, because it is image data. So images has some depth, and if we are processing some dog images, so after if we are learning, our model is learning about the nose, then there is some depth. Okay, so there is some descent and gradient. So those data are three-dimensional data. What my point? So that's why we are showing here 28 by 28 into 192. So these are the different architecture, the convolution they are using to develop the model. Batch normalization in the inception. Batch means how many uh, the pixels of the batches we are processing together. Okay, so batch regularization means we are just summing all the absolute values of the weights. Okay, and we have to check whether which data is used or not. That means learning rate. Learning rate, we do not pass through the all pixels to learn about the data. Okay, we have to jump off. So we have to just check that whether these data should be processed or not. Okay, so we have to remove it. Okay, here it is removal of dropout. So increase learning rate and decay. Okay, removal of L2 weight regularization. L2 means L1 means sum of absolute values of the weights, and L2 means sum of squares of the weight. These are the just mathematical terms. How we are processing the information of the pixels of the image. Okay. So removal of local response normalization, reduced photometric distortion, one more 28 by 28 insertion, changed cooling system scheme. So these are the architecture. That means how we are processing the data to get the result in our way. Okay. So if you have the idea to develop some neural network architecture, and for that you have to understand lots of topics and the previous pre-trained model. You have to understand about that, and then you can process the new model. Okay. How they are just applying. Filter means kernel, convolution. Okay. All are the same things in different word. Okay. You don't have to confuse. We are just applying that these pixels of information are just we are just checking, just picking the single uh, not single. That means we are picking a batch of the images, and we are just processing by in the different matrices. Okay, so it may just process the faster processing. So we have to just create different types of benches. Of the, that means first node is taking 5 by 5 matrices. Second node is taking 3 by 3, 1 by 1, and some functions are working there to because some in the architecture of the neural network, we have some functions also are there to process the next level of data. Okay, these are the differences of the function 2, 3. You can uh, understand here now. Here you can see here how many types of architecture they are using in the different version. Okay, how they are filtering the images. Further grid size reduction, parallel stride, to pooling and stride to convolution. Okay, so these are all the topics we had discussed. What is stride? Okay, how many steps we are moving in each step? Okay, that is called stride. And what is padding? We observe the size of output is smaller than input. Okay, so maintain the dimension of output as input. We call padding. Okay, so you have to apply some all the techniques to make a neural network. These are the techniques which is used: factorization of 7 by 7 convolution, used RMS crop optimizer. So these are the label smoothing. These are the techniques they are using. Okay, here you can see into the images. Inputting 299 by 299 into three matrices of the data, and then some stem, uh, and then processing uh, those data into, that means we are just normalizing the data, batch normalize. 4 into inception A, that means 35 into 35 into 384. Then we are reduction A. So these are the named given by the developer, and they are just using different filtering techniques to process the data. Okay. Finally, they are applying some softmax function to combining all the pixels information to create an image. Okay. So in the last layer, we have to use the different types of functions. Okay. In the final hidden layer, some mathematical functions are there to process all the data to finalize the output. Okay. Inception-resnet, um, MobileNet. This is the different name of the architecture of the neural network. That means UNet, ResNet, MobileNet, LENet. Okay. So they are using different type of VCC, video graphics group. Okay, visual graphical. They have some known of the VCC. We had already seen visual geometric group. Yes. Visual geometric group. So they are just creating their group name and putting the name into the developed model. Okay. Depth-wise convolution, point-wise convolution. So they are just separating all those architecture by, here it is the filter or the kernel of the convolution. Okay. So these are the weights of the pixel. Okay. So what are the logic they are applying? This is GX, this is GY. Okay. So how the images are identifying, because if we are putting values, so it have to be processed by the processor. Now, if we are just putting zeros between two numbers, so now this pixel can be identified by that the, that up, before plus one there is zero. Okay, so processing zero is very taking very less time. Okay, so these are the techniques how to we are applying the weights of the pixels. So these are the techniques. So now we are applying the filter. That means the ages of the object, the information about the ages of that object here more highly required here. That means plus two means we are putting this pixel more more priority. Okay, and this is not the ages of the object. Okay, that's why we are putting zero. This is a less part of the. edges. So these are the technique we have to use. This is not by the manually. Okay, you have to develop the function or the different architecture. So they will use that. So now all the process matrix will be processed like that, one by one. How all the calculations are just giving you how we need to just converting those pixels into which architecture, how many uh, convolution we can use. Okay, here you can see that these are the layer. Okay, the boxes are called layer. These are input layer, these are output layer, these are hidden layer. Okay, these are hidden layer. There is some uh, functions are applied here. So you have to understand like depth-wise convolution and point-wise convolution.